Uh, okay, this today's my lecture is about introduction to machine learning. So, what is machine learning? Machine learning, in other words, we can say that it is automated automation. We can get means getting computers to program themselves, then writing software in the bottleneck, and then let the data do the work itself or instead. So what is mean in what from where it comes? So Herbert Simpson he has given the definition of machine learning. He told that learning is any process by which system improve performance from experience. Means how much we have the performance, we can increase the output of that system. For example, if I'll say that a doctor is having, for example, 1 year experience doing practice and a doctor of having 10 years of experience doing practices. So, naturally, the person who has the good experience, much lot of experience, his performance better than the person who has the less experience. So, same thing is there. So, in other words, I can say that machine learning is concerned with computer programs that automatically improve their performance through experiences. Uh, now, if I'll explain in terms that machine learning, so definition by Tom Mitchell, 1998, he has given. He told that machine learning is the study of algorithm that improves their performance P, at some task T with experience. If the person is having, if a machine is having experience, so improvement in the task will be there. So well-defined learning task is given by P, comma T, comma E. So concept of learning in a machine learning system, we can say like this: learning is equal to improving with experience at some task. So improve over task T with respect to performance measure P and based on experience E. Now I'll tell you regarding the traditional programming and the machine learning. In traditional programming, as you are seeing in the PowerPoint presentation, we in computers we are having the data, we are having the program, computer process it, and we are getting the output. But in machine learning, what exactly we have? We have the data, we have the experience that we are calling as the output, and on that basis we are making the programs, we have the program. So this we are calling as the machine learning is. So when do we use machine learning? Machine learning is used, for example, if human expertise does not exist, so then human cannot explain their expertise, for example speech recognition, then models must be customized, personalized medicine. Then models are based on amount of data, genomics that can be. And it is not always, learning is not always useful also. For example, there is no need to learn to calculate payload. So this is very interesting and classical example of machine learning, means a classic example of a task that improve machine learning. It is very hard to say what makes it to, if you'll see in the figure, but with the help of the machine learning, that can be done. Some more examples of the task that are best solved by using it. learning algorithm. For example, pattern recognizing patterns, facial identifies or facial expressions, then handwritten or spoken words, then medical images. So, in recognizing pattern, machine learning algorithms are very useful. Then generating pattern, for example, generating images or motion sequences, any motion, any car or any object is moving. So to generate this motion sequences or to generate an images that machine learning algorithm helps. Then recognizing anomalies means unusual credit card transactions that can also be uh, in this case also machine learning algorithm is very useful. Then unusual patterns of sensor readings in a nuclear power plant. So this is also in this case also machine learning algorithms are very useful. Then prediction, for example, future stock prices or current exchange rates. So in this case also, because on the basis of the performance, on the basis of the experience, machine learning algorithm can be implemented. We can get the good results. Prediction can be done for future stock prices or current currency exchange rates. Some few examples are of machine learnings that web search also computational biology, then finance, then e-commerce, then space exploration, then robotics, then information extraction, then social networks, then debugging softwares, and it can be any your favorite area that machine learning application can be. Some olds checkers players, machine learning means field of study that gives computer the ability to learn without being explicitly programmed. That is uh, Arthur Samuel in 1959 he told about this thing. Defining the learning task mean is on the basis of experience improve the task with respect to the performance. So this is so task we are represented by T, performance we are represented by P, and experience we are represented by E. For example, if I say T means task, link means that playing checkers. P can be in this performance can be the percentage of game won against an arbitrary opponent, and E experience means playing practice games against itself, right? This can be the one pair. Then another is T task means recognizing handwritten words. P P performance means percentage of words correctly classified. E can be the database of human labeled images of handwritten words. Then another can be T task means driving on four-lane highways using vision sensors. Means performance means average distance traveled before a human uh, judged error. And E for if I'll say experience, a sequence of images and steering commands recorded while observing a human driver. Then, like this, one more example we can take. T means task, categorize email messages as spam or legitimate. P means performance means percentage of email messages correctly classified. E database of email, some with human given labels. Some state of arts application of machine learning. This autonomous car is there in June 2011. Nevada made it's legal for autonomous car to drive on roads. Then in 2013, four states, Nevada, Florida, and California and Michigan, have legalized autonomous cars. So these are the examples. And autonomous car sensors are in such a way that obstacle detection lidars, then stereo cameras, then GPS, then 360, 3D mapping, learning from human vision. So all type of technology in this autonomous sensor cars we are using. And then simultaneously, again things comes and the deep learning. Deep learning means computer learning and growing on its own, well, able to understand complex, massive amounts of data. That comes as the deep learning. So deep learning later on, I'm going to explain you about the deep learning. Means we have the pictures that A's is, if you'll see in PPT, then object part combination of phases, then object model we have. So like this, we are giving some input in ACs and accordingly things comes. So this is learning of object parts. Things come in such a way. Means trained on four classes: cars, faces, motorbikes, and aeroplanes. Second layer will share features and object specific features. Third layer is more specific features. Like this will be there. Later on, the things can be explained. Now I'll come about the type of learning. Different type of learning we have. One is supervised inductive learning. Supervised inductive learning. In this, we have the training data and we have the desired output. What which type of output we want that we this we are calling as the supervised learning. We have training data without desired output. Well, desired output is not there, or we have the training data. And semi-supervised learning means training data and few desired outputs are there. And the fourth one is reinforcement learning means rewards for sequence of actions. So this comes as the four type of learning. Supervised means inductive learning. Second is unsupervised learning, that is training data without any desired output. Semi-supervised learning means training data with few desired output, and reinforcement learning means rewards from sequence of actions. If you will see in this figure, then supervised learning means training data with desired output. Supervised learning means no desired output, and semi-supervised means uh, few desired output is there. So the examples are there in supervised and unsupervised learning, and semi-supervised and reinforcement learning. Then if we designing a learning system, so what exactly we need? We choose the training experience, then choose exactly what is to be learned, means target function, and choose how to represent the target function, and then choose a learning algorithm to interfere the target function from the experience. So if you'll see the figure, then environment or experience from their training data and testing data. So learning, knowledge, and performance element. So things are there. One is choose the training experience. Secondly, choose exactly what is to be learned, what exactly we want, target function. Then choose how to represent the target function, in which way we will represent the target function. Then the fourth one is the choose a learning algorithm to interpret the target function from the experience. So this is what it is about the machine learning. Training, what's its testing distribution? We generally assume that the training and testing examples are independent, same overall distribution of data. So we can call this IID, which stands for independent and identical distribution. If examples are not independent, requires collective classification. If test distribution is different, require transfer learning. So machine learning in a nutshell, we can say that tens of thousands of machine learning are there, and every year hundreds new algorithms are coming. So every machine learning algorithm has three components. One is the representation, second is optimization, and third is evaluation. Now, various function representation. One is numerical functions, then linear regression, networks, vector machines. Symbolic functions can be the decision tree, then rules in proportional logic, then rules in first order predicate logic, then instance-based functions, the nearest neighbor, case-based, probabilistic, graphical models, then Naive Bayes, Bayesian networks, then hidden Markov models, then probabilistic context-free diagram, then Markov networks. And few various research, search and optimization gradient descent, then perceptron algorithm, dynamic programming. In dynamic programming, hidden Markov model learning, then PCFG learning, then divide and conquer, then decision tree induction, then rule learning. Evolutionary computation, genetic algorithm, genetic programming, and neural evolution. Then comes the evaluation. Evaluation, we are having the accuracy, we are having the precision in the call, then squared error, then likelihood, then posture probability, then cost and utility, then margin, then entropy, then KL divergence, etc. In machine learning practice means first we should understand domain, prior knowledge and goal, then data integration, selection, cleaning, pre-processing, etc. Then learn models, then interpret results, then consolidate and deploy discovered knowledge. So uh, if I'll tell you about the brief history of machine learning in 1950, Samuel's checkers play comes, then Selfridge Pandemonium, then 1916 neural network, perceptron, then pattern recognition, then learning in the limit theory, then Minsky and Papert improve limitations of perceptrons. 1970 symbolic concept induction, Winston's arc learners, then expert systems and the knowledge acquisition bottleneck, then Quillen ID3, then Michael EAQ and Sabian scientific discovery with Bacon, then mathematical discovery with Gale. Then comes in 1980s, then advanced decision tree and rule learning, then explanation-based learning, then learning and planning and problem solving, then utility problem, then analogy, then cognition architecture, re, resurgence of then variant tech learning theory, then focus on experimental methodology. In 1919, data mining, adaptive software agent and web application, text learning, reinforcement learning, inductive logic programming, then assembles, bagging, boosting, and stacking, these net learning. Then in 2000, support vector machine comes, then kernel network, graphical model, statistical relational learning, then transfer learning, sequence labeling, collective classification, and structured output, then computer systems application, the email management, and personalized assistant that learning in robotics and vision. 2010 and so on comes the deep learning system, learning from big data, Bayesian method, the multitask, and lifelong learning, the application to vision, speech, social network learning to roles, etc. So this is all about the basic fundamental things about machine learning. So next lectures I'll start with a little bit uh, few more things that can different type of machine learning models that can be geometric model, logical model, probabilistic models, etc. etc. So thank you. If any query, then let me know. We'll discuss later on. Thank you.